So, in this lecture, I'm going to talk about a radiative formula from an accelerated charge, and the charge is moving with a very low velocities. And this formula is known as Larmor's power formula. So, if charge is moving with a very small or the low velocities, so that means the beta which we are defining u by c, this is very much less than 1. So that means beta can be ignored in this case. And another thing which I want to recall, the expression for electric field, and this is a component of electric field containing both velocity and acceleration component. So I am recalling this expression, and this expression is nothing but E upon C 1 over R minus beta dot R, its whole cube, and here it is R cross R minus beta R cross beta dot its acceleration component, and this is the retarded time. So I am calculating this for the retarded time. Now, as if I use this particular approximation here, so that means this beta can be ignored from here and this beta can be ignored. So if this can be ignored, so that means whole of the term can be ignored, and similarly this term can also be ignored. If I ignore this, then this expression will become, and I also ignored the square bracket for the sake of simplicity. So here E upon C R cube, this is R cube because I ignored this term, and here it is R cross R, and it's a cross this beta dot. It can be written as U dot C, or you can call it as A dot C, A upon C. So if I express it as A upon C, then how this will become? C is there, and this C can be written with this, so it is E over C square R cube, and it is R cross A, and I will use this identity, that is A cross B cross C, it is equal to B A dot C minus C A dot B, right? If I use this, then this can be expressed as, this is E upon C square R cube, this is R dot A into R minus A R dot R. This can be written in this manner. So if I can express it as R dot A also. So keeping this in mind and this towards this and this towards that side. So how it become? It will become E upon C square R cube. It is R dot A into R minus R square A vector. So this is the way that how it can be expressed. Now similarly, I can find out expression for dA, and this dA is equal to R cross EA upon R. If R cross upon R can be written as n cap, so that means it will become n cap cross EA. So now, because Poynting vector represents the radiative power, so that means we have to find out the Poynting vector. So how we will define Poynting vector? So let us see that this Poynting vector is equal to C over 4 pi EA cross BA and is equal to C over 4 pi EA cross n cap cross EA. And this EA cross n cap cross EA, it can be expressed as n cap EA minus EA n cap EA. I can express it in this manner. Also, I know that they are perpendicular. If they are perpendicular, then this value will become 0. So that means this is simply equal to C over 4 pi EA square, because this can be expressed as EA square. So it is EA square n cap. Now we have to calculate the value of EA square. So that means my next purpose is to find out the value of this one. So for this, let us consider EA factor is equal to E over C square R square RAR minus R square A vector. So I will use this identity. So taking square on both sides, so it will become E square C4 R6. And here, if I take it square, then it is RA R vector whole square minus 2RA and it is R and R square A vector plus R square A vector whole square. That's what we are getting here. This can be written as RA cos theta. This can also be written as RA cos theta. Similarly, if I take R square outside, then these two terms collectively written as RA cos theta. So this is RA cos theta, this is RA cos theta, so it is R square A square cos square theta. And it can be written as R square A square cos square theta into R square. So that means r square a square cos square theta into r square minus 2r square a square cos square theta, and this r square can be taken outside, plus r4a square taking r square outside. So what is it? It is ra cos of theta cos square theta minus 2r square a square cos square theta plus r square a square. So now it is equal to e square over c4 r4, and if I club these two terms, then it will remain with r square a square cos square theta. So it can be written as r square a square minus r square a square cos square theta, right? So it is e square a square c4 r4, and r square is outside, so it is 1 minus cos square theta, and this r square will be cancelled out with it. That means it is e square a square over c4 r square sine square theta. So now this is the expression for E a square. Now we have to use this E a square in the expression for Poynting vector. So the Poynting vector will become S is equal to C over 4 pi E a square n cap. So it is C over 4 pi E square a square 4 pi, sorry, not 4 pi, but it is C4 r square sine square theta, and cap should be there, and this c will cancel out with this, so it is 3. So in this manner, this Poynting vector will become e square a square over 4 pi c cube r square sine square theta n cap. Now we have to calculate the power radiated per unit solid angle. So power radiated per unit solid angle is defined as, it is dP over d sigma. It must be equal to Sn and r square. So if I substitute value here, so it is e square a square 4 pi c cube r square sine square theta n cap, and multiplied by with it dot n cap into r square, and this r square will cancel out with it, and n dot n is 1, so dot product. So now it is e square a square over 4 pi c cube. So this is the expression for radiative power per unit solid angle, but this is for time t, but we have to calculate this expression for retarded time, that is t naught. So for this we can make changes, that is dpt naught over d sigma. It can be expressed as dp over d sigma into curly t over curly t naught, but curly t over curly t naught is equal to k over r, and this is r minus beta r. This is not there, right? So it is r by r. It can be expressed as 1 minus beta n cap, and this can be ignored here. So keeping this in mind, if we will ignore it, then this will become equal to 1. So that means the expression for it is e square a square 4 pi c cube sine square theta 1 minus beta n cap, and this is ignored for smaller velocities, or the particle moving with the very small velocity. So that means this is e square a square 4 pi c cube sine square theta is the expression for it, right? This is the expression. Now total radiated power can be obtained by integrating this. So it is pt naught is equal to this, or this can be expressed as e square a square 4 pi c cube. It is 0 to 2 pi. It is t phi, and this integral from 0 to pi sine square theta, and it is sine theta d theta, and the value of this integral comes out to be 8 pi by 3. So it is e square a square over 4 pi c cube into 8 pi by 3. This will cancel out with it and it with this, so it is 2e square a square over 3c cube. So thus these two expressions, dp over d sigma, sorry, d omega, and this p, these are the Larmor formula. So that means this is equal to e square a square over 4 pi c cube sine square theta, and p is equal to 2e square a square 3c cube. So these two equations are known as Larmor formula for power radiated by a accelerated non-relativistic charged particle, right? So with this article will finish, and thanks for watching this video.